And welcome to today's webinar, A Developer's Guide to LTI Resource Search. We have an esteemed slate of guest speakers today, including Adam Blum, Senior Director for ACT, Paul Deve from Pearson, and Vikash Jaiswal from ACT as well. And I'm Jill Hobson. I am a K-12 Institutional Program Manager here at IMS Global. And with me today is Kara Jenkins, our Director of Marketing Communications. For those of you who may not be familiar with IMS Global is all about helping EdTech suppliers and institutions be able to improve the business of EdTech across the ecosystem. Through many different areas of focus, we have opportunities for folks to get involved, to learn more, and to implement standards that help drive change and innovation. And so without further ado, I would like to turn it over to Paul to begin our session. Paul, take it away.
Hi, everyone. My name is Paul Deve. I'm a software architect for Pearson, and I guess let's get this going. So maybe first up, for those, I'm assuming people are familiar with the LTI Resource Search, but just in case you're not, so the specification for LTI Resource Search defines the APIs that need to be exposed so that someone can search your learning object repository. Or, I guess the important thing is you're trying to figure out who you are. So if you're a consumer of the LTI Resource Search specification, then you are the person who is writing REST calls to find out the subjects that are available in a learning object repository and then search those based on criteria. If you're a provider, then obviously you're on the other side of that. You're the one who's writing those REST API endpoints and making sure that they conform to the specifications. So for today, I'm primarily focused on the details of being a consumer, just outlining what the API endpoints need to look like and how to interact with them. And then if you are going to be a provider, I think you should be able to take that knowledge and turn it into your implementations for how to meet those. So first up, LTI Resource Search has really two core endpoints that it's exposing, or that they're exposing to conform with specification. So first up is the subjects endpoint. So we know learning object repositories they're going to support a wide variety of subjects, and because of how drastically different those subjects could be, we want those repositories to be able to expose to someone which subjects they actually support, so that if you are constructing searches on their repository, you can intelligently construct those searches so that you're not looking for math content items in a repository that is primarily focused at social studies. So once you have the available subjects, the other and most important endpoint that you'll be calling is the resources endpoint. So this is the endpoint that accepts search criteria that then, once you pass in the correctly structured search, returns the list of learning objects that you can interact with. So the LTI Resource Search specification does not say that these endpoints have to be secured, but it does say that if they are secured, they should be secured with OAuth 2.0 endpoints. And so really that means that if you're communicating with a secured LTI Resource Search endpoint, you're probably also having to fetch an OAuth token. And so you're going to be interacting with a token endpoint. Now, this token endpoint might not actually be called /token, but it is to the OAuth endpoint. So first, we're going to talk a little bit about authorization. So just in case the repository that you're searching is secured, if those endpoints are secured, you're going to need an OAuth token to be able to communicate with these things. So for our example here, we know that the OAuth 2 specification, there are a lot of different grant types that somebody can use So when you are having to fetch a token to be able to call, just to be able to search a secured resources endpoint, your interaction to get a token might be slightly different. But for our purposes here, since OpenEd has nicely exposed a resource search to be able, a resource repository to be able to search, this is how you get a token from their endpoint. So to be able to get a token from their endpoint, you need a username, which is OpenEd's repository provides, a client ID, which is really that is your application's identifier, and then the client secret, which is your password for obtaining the token. So of course, don't give that out. In order to obtain a token, the first thing you need to do is you need to take your ID and you need to take your secret, and you need to munge those together, concatenate them together with a colon in between, and then you need to base 64 encode that string, and that string is what you're going to use on your call to the token endpoint in order to request your token. So that is the encoded version of your username and password, really. And of course, base 64 encoding, whichever language you're using, there's probably a utility for it or a JavaScript library that you can get. If you're just doing this for fun in an application, like let's say Postman or something, there are websites online that will base 64 encode strings for you very easily. So once you have your base 64 encoded version of your ID and your secret, then you're going to need to make a call to the actual token endpoint. So for OpenEd, that means one, your URL is you're doing a post to this OAuth get token, and then you need two headers in order to be able to get your token. First, you need an authorization header, and this authorization header is where you're going to include that base 64 encoded version of your credentials. So because this is a username password, then this is a basic authentication. So your authorization header is going to be, and this is important, this is the string that you will include is basic with a space, and then the base 64 encoded credentials. You'll see later for our resource search endpoints, you're going to be using bearer authentication, so your authorization header will look very similar. The next thing you need is another header. Since you're going to be passing JSON in the body, we need to tell it that. So you're going to have a content type of application JSON. And then last, you are going to be in the body telling the token endpoint what your grant type is, and this is client credentials, and then also what the username was that OpenID has given you. So OpenID, I think their username needs to match their records for their client ID, so it's an extra level of security there. But once you make your post, then you are going to get back some JSON that contains your access token. This is going to be your ticket to being able to search their repository and view the subjects that their repository supports. So obviously, look at you'll want to extract that access token and save that for later because you're going to need that on your future calls. So and so here's what I was talking about. In order to make those secure calls, so we don't have to cover this for each of these endpoints as we make these calls. The key is you're always going to need an authorization header, and then you're going to take that token that you got previously, and your authorization header's value is going to be bearer space and then the token that was given to you, and that's going to be how you pass those credentials. If you forget to pass those credentials and you're trying to call a secured resource search, or most likely the thing that I forget to do or is like I leave off the space or I forget bearer on my authorization header, then you're going to get back a payload that looks like this that tells you that you're unauthorized. So if you're getting unauthorized, you know that there's something wrong with your either your token is expired or your header was probably incorrect. But assuming that you can construct that properly, then now we can talk to our resource search endpoints. So first, subjects. So as I said, this is the endpoint that that tells the caller which subjects the resource repository supports. So again, this repository can be very specific. It can contain just math resources, or it can contain a wide variety of resources. And since subjects, they can be very specific, it's not a controlled list. We want the repository to be able to tell you that, hey, we support geometry and trigonometry, and that's it. So to call the subject's endpoint, it's actually, obviously, this one's very simple. It turns out there's no query parameters you need to pass. It is just a GET call to the subject's endpoint. One thing to note, so the IMS endpoints have some versioning information on them. So you'll want to include that versioning information. Yeah, your endpoint, when the repository gives you the endpoint, it'll have this information in there. But that's what the IMS RS P1 P0 is for. But you're making a GET call to the subject's endpoint, and then, like I said, if they've secured that, then you're going to want to include that authorization header with the token in your included. Of course, if the endpoint is not secured, you don't need to worry about that. When you make the successful call to the endpoint, then here's what you're going to get back. You're going to get back some subjects JSON. Subject JSON is it's an array of subject objects. Each object has an identifier, which is the internal identifier for that subject from the repository. And then subjects can have parent-child hierarchy, but the JSON that gets returned to you is a flat list. So in this case, if we're looking, this repository supports mathematics, geometry, and algebra. And you can see that based on these parent IDs, geometry and algebra are actually children of mathematics. If you want to render this in some sort of user interface, if you're letting somebody build a search visually, then you're going to want to make use of this parent-child relationship. But it's worth noting, and we'll see later, when it comes time to do your searches, the name is actually the important part of what you'll be using. So we've run a subject search. We know which subjects our repository supports. The next thing that we need to do is search the repository. So the main endpoint for this is /resources. Very simple. This is the core endpoint of the LTI Resource Search specification. And through appending query parameters on your GET call, you'll be able to do complex searches. You'll be able to sort the data that comes back. You'll be able to page through data. So if you're looking at very large result sets, you can fetch just records 10 through 20 if you want to allow somebody to page through it. And then, although we don't cover it in this presentation, you can, in these slides, you can also control which fields come back in the resources that you search on if you want to reduce the amount of data that's coming back from the resource search. So let's look at what one of those calls look like. So just like subjects, very simple. We've got, you can just make a call to the resources endpoint without any other information. Obviously, you'll need the authorization header if it's secured, but you can just make a GET call to /resources. And that's going to give you the default behavior for the resources endpoint. And in the specification, it says the default behavior is to return the first 100 resources in the repository. Obviously, you didn't specify sorting, so it is at the discretion of the resources endpoint which 100 resources you get. But in order to not overload the resources endpoint, the specification says you're not going to get every single resource in their resource repository. So when we make that call, we're going to get back, similar to subjects, we're going to get back the resources JSON. And the resources JSON is an array of resource objects. These resource objects can have a lot of information in them. And for full details on all of the fields that can come back, definitely take a look at the LTI Resource Search spec. But for our purposes, here's kind of a pared down example. You can see we've got the ID of the resource inside the repository. we've got a name, we've got a description, publisher, and then the subjects that it is attached to. In this case, we've got mathematics, and remember our repositories for mathematics, geometry, and algebra. And then also one of the most important things, we've got the URL, which is going to be your way to, once you've found this resource, your way to access that resource. But let's be honest, that use case, just calling a get on /resources, is probably not how you want to be fetching resources from a resource repository. So for that, you're going to need to get into building filters. Filters are the idea, or is the way that we run searches on a resource repository. A filter consists of a data field, which is obviously the field that you care about, that you want to filter on. Predicate, which is how you want to match on that field. So there are quite a few different predicates that are supported, but I think the most important ones to know are we've got equals, of course, if you want an exact match. But then we also have the tilde, which is a contains. So if you want, and as we will look at later, if you want to find all of the resources whose descriptions contain a certain word, this is the predicate that you'd use. If you're searching on a value that is numeric, you can also use greater than, less than equal to, those sorts of things. And then last, of course, you're going to need a value because you need something to match on. So to construct a filter, you are going to take a data field, your predicate, and your value, concatenate them together. No special characters in between them. In this case here, we've got a little wrapping problem. But in this case, we've got, if we're going to search for all resources who are in the geometry subject, then the filter is subject equals, and then since we're dealing with a string, you need to wrap it in the single quotes. So subject equals quote geometry, single quote geometry, single quote. Of course, these are going to be tacked onto your URL as query parameters, or your get URL. So you do need to URL encode these values. So that's for people. I'm assuming you're familiar with URL encoding, but just in case you aren't, there are certain characters in the query string that will cause the URL interpreter to behave in different ways, and you want the URL interpreter to ignore those so that they get passed through. So in this case, subject equals geometry turns into the very friendly looking subject %3d %227 geometry %27. So once you've URL encoded your search, then you're going to tack it on the end of your query string. So the query parameter for running the search is filter. So you're going to make a get to resources, and then the question mark for your first query parameter. Filter equals, and then you just tack your URL encoded filter right on the end. And what this is going to give you is since we didn't specify a number of records or a sorting, this is going to give us up to 100 records in the resource repository whose subject is geometry. Subject searches do take into account the parent-child hierarchy of subjects. So let's say we search for mathematics, then we're going to get resources that were tagged with geometry or tagged with algebra because the search knows that those are children of mathematics. So that's our simple search. But of course, you're going to want to do more complicated searches than that. And so for that, it's very simple filter chaining. So in this case, construct as many of your filters as you need, data predicate value, data predicate value. And then you can combine them using ands or ors. So in this case, let's say we want all the resources who are in the geometry subject, but very specifically, we are looking for resources that have to do with triangles. So we construct two filters. We've got subject equals geometry, and then description, and we're using the tilde predicate here, triangle. So this is saying description contains the text triangle. So we combine those together with an and then URL encode them together, and then we get this very pretty looking string at the bottom. And then just like before, to run the search, just like before, to run the search, you are going to tack this on to the end of the if the question mark filter equals, and then this, and when you run your get, then the repository is going to return to you the results whose subjects are geometry and whose descriptions contain triangle. So this is how to construct complicated queries. But again, this could give you way too many resources. And maybe not the correct set of resources if your maybe result set is over 100. So in that case, we're going to need to get into sorting. So sorting is very simple. Sorting has two more query parameters that you need to include on your query. First is sort, which is of course the name of the field you want to sort by, and then the second is order by. Whoops, apologies, my examples here. It should be order by equals ascending. So order by, sort the field you want to sort by. Order by is either ascending or descending, of course. If it's alphabetical, then ascending is A to Z, descending Z to A, numeric, you get it. But if you were to search for, run your search and also tack sort equals name and order equals ascending at the end, then you would get the first 100 resources that were in the geometry subject, had description of triangle, sorted by sorted from A to Z. If you want a smaller result set, you have the ability to page through these results. So let's say our query for the geometry resources with triangle and the description was going to return us 500 records. But we're building a UI that is we only want to show 10 records at a time. So in that case, you're going to want to use two other query parameters. You've got limit, which is the number of records you want back, and then offset, which is the record index to start with. So when you are querying, or when you're searching a repository and it figures out you have 500 records it's going to show, those records kind of get put into an array. Think of them as being in an array, sorted by whatever you wanted it sorted by, as zero-based indexes. So if you wanted the first 10 records, your limit would be 10 and your offset would be 0. It's like, I want 10 records and start with index 0. If you wanted the next 10 records, then your limit would still be 10, but your offset would be 10. Because you've already seen records 0 through 9, now you want to get the next 10 records. Little pro tip: when you run a search, in the headers that come back, if you have specified, or if in the headers that come back, it will automatically construct paging URLs for you that you can extract if you want. So if you're searching for 10 records and you got records, 0 through 9, there will be you'll be able to see a URL in there that says, hey, the next page is this URL. So a nice little perk. Of course, all that combined together, here's what your query would look like. So there's a simple get call to /resources. And then, you've got your question mark that starts your query parameters. Your filter query parameter is your subject is geometry. And then your sort is by name. Your order by is ascending. Your limit is 50 and your offset is 100. And what this means is I want 50 resources, 50 geometry resources, starting with 100, record 100, sorted by name from A to Z. So yeah, I think pretty clearly you can see that constructing these queries is relatively simple. And then you can chain as many filters as you want together, although it is recommended to keep that chain small. Yeah, so that is it for the basics of talking to the search endpoint, talking to the resources endpoint, and making sure that you're including the right authorization headers in your searches.
Thank you so much, Paul. And I want to remind all of our participants, we would love for you to submit your questions via the Q&A or chat. We are going to hold questions till the end, but please go ahead and start submitting those as you think of them. And now I'm going to turn it over to Adam.
Okay, great. Thank you, Paul. That was a great overview of LTI Resource Search. Now I'm going to jump into showing a sample client that we really hope will accelerate your implementation efforts. This is actually open source under Apache license. It's on GitHub. Jill and Carol will be sending out links later, but it will include this link. And so this is a simple command line interface for doing LTI Resource Search. It has various options. The ability to apply a key and secret if you're connecting to a secured endpoint. Some endpoints, including the OpenEd endpoint, do request that the user ID be included in the payload, so there's that option. Some endpoints look for form-encoded data. That was one of the things about in Paul's example, where he talks about providing the grant type, for example. If you are going to get certified by IMS, as I mentioned in the chat, you will need to form encode any data payload in there. There is a special capability that Vikash will talk about providing a search attribute, which actually searches against multiple text fields, specifically usually name, subject, and description, but it's up to the lore, so you can provide a -S option to do that. You can search for the resource type with -R. You can provide the publisher as a filter, or you can search based upon the learning objective, and that's something I want to go into more detail. Just what are these learning objectives, and what does it mean to search by them? Before I do, you can just see here's an example. This happens to be a Ruby program where we are supplying command line options of the key, secret, the endpoint, where you get tokens from as the -T option, provide the user ID, and then it's actually searching for a learning objective of k.cc.1. So with that, and by the way, of course, it's not really realistic that anybody would use, an end user would use the command line option. The hope here is that as you build these out into your web interfaces or your other full-fledged applications, that this can be a great way to just sort of simplify that process of what it means to write that code. So now what I'm going to do is talk about what does this mean to search by learning objective. I'm actually in the REST JSON binding spec for LTI Resource Search. There are quite a few spec documents. This probably does the best job of breaking down like just what are these attributes that you care about. So if any of you are familiar with either LRMI or schema.org, you may notice that LTI Resource Search is quite similar to it, but very much by design. One of the things that, however, those standards for describing resources don't do is talk about case. Case is an IMS standard for talking about learning objectives. So learning objectives were there before. You can search by learning objectives.target name if you want to search by, say, a human readable name. And that's been in not just LRMI and schema.org, but also in other standards like Common Cartridge for a while. Because case is now a standard for referring to learning objectives by URI or GUID, we now have expanded this learning objective structure to include that. Now, let's get away from the abstract and talk about, how do you really find these learning objectives? So IMS is the sponsor of another effort called the Case Registry, and this is out at caseregistry.imsglobal.com. I've now surfed around and I've found a specific learning objective here called 6.g.a.1 within the Common Core, and we can now search by search by this 6.g.a.1, or we can search by an identifier, a GUID. We can also search by the actual URI that is associated with this. So let's show what that search really looks like. Now I'm going to actually jump to a debugger just so you can see how this gets done inside an actual application. So this is the this happens to be Visual Studio Code, but these principles will apply to any debugger. What I'm now doing then is I'm going to first launch it within Novation, and I'm going to give it a key and a secret with the -I command and the -K command. I'm going to give it the token OAuth endpoint. I'm going to give it a base name to do this. I'm going to give it a username, and then I'm going to search for this specific standard. It turns out both either 6.g.1 or 6.g.a.1 will work. Novation's done an awesome job of supporting both these syntaxes. So now I'm going to go start debugging, and you can see that this launch.json file lets me have a debug configuration. I'm going to use the Novation one, and I'm going to step through this code. So what I've done is I've now started execution, and it's going to parse through the command line options. And at the end, we have a set of search criteria, and the search criteria is learning objectives.target name equals 621. So we're going to keep stepping through. One of the first things we'll do is do a get token. You can see we're going to take the key and secret. We're going to go to that token URL, and we are going to get a response back. This is our bearer token that Paul was referring to. And you can see we're embedding this now in there, that bearer token. And we're going to go through here. There are command lines to go get subjects, but we didn't invoke that particular command line option. What we're doing here is we're just building up this URL that Paul was referring to. And so we're going here, and now we have this is going to be our final URL that we are going to execute. And you can see that we're going to hit this specific URL, and it's going to take a little bit because it's actually executing it, and then it actually gets a response. We're going to parse that JSON. Going to keep stepping through. And what we're going to do is actually print out, we're going to print out the resources that come back from this after it hits this URL. Okay, it's a little slower inside the debugger. I'm actually going to show this from the command line where we're calling .novation. With a shell script that you can see. We're going to hit against Novation, and we're going to get a bunch of resources back. And so you can see we've got a bunch of resources, a bunch of Brain Genie resources, CK12 resources, and we happen to be returning the title, tab separated from the URL, tab separated from several other bits of metadata. Okay, so now what I want to show you is that you cannot just search by the human readable name. We want to actually show that you can search by that GUID. So we will go to the standard here, and you can see we've got an identifier here. And I'm now going to, now have an OpenEd configuration. You can see we have a key here, a secret. Oh, let's go back to launch JSON. And so here we have, for OpenEd, we have a key, a secret, a base name for the API. A base name for the API, the user, and then we actually have this GUID pasted in with the -o command, the learning objective search command. So I'm going to say that what I want to do is I want to launch it with the OpenEd configuration and with these parameters, and I will go ahead and start debugging. And so we're now inside here, and we can just step through. And you can see we have some search criteria here. The search criteria are learning objectives.case item GUID, of that particular case item GUID that does the search for 6G1. We're going to go through, get the token, use that in our code, build up a URL. And you can see it's hitting now a different URL, partner.opened.com, IMSRS v1p0, resources. We're asking for the ID, the LTI link, the URL description, and the name back. And we're searching, the filter is learning objectives.case item GUID equals this particular GUID from case. And so we'll step over this. We've got this response that we JSON parse. And let's just go ahead and finish this up to the end. And you can see it brings back a whole bunch of resources. There's an example of this resource that's entitled triangle, and this is the URL on OpenEd, and then it has a description afterwards. And by the way, this is all checked in, including all these various configurations, so you should be able to try this on your own. Our goal here was that hopefully if you decide that you're interested in implementing as a client, you can start with this code that we have here, and it should accelerate your efforts. So, so with that, I'm going to turn it over to Vikash to talk about some more advanced topics. Take it away, Vikash.
All right, thanks, Adam. Okay, so wow, what a presentation so far. It's becoming hard to follow Adam and Paul every day. I will be talking through 3 different items broadly. One is something that Paul touched on, is the subjects endpoint, and just walking through that in a demo fashion. Talk about the magical search parameter that Adam touched on, and then talk a little bit about identifying error and zero results and what that means and how we can go about trapping those things. So let's get started with the subjects endpoint. As Paul pointed out, the idea behind this endpoint is in the absence of a standard as of today for subjects across learning repositories, we came up with this endpoint as a way for calling applications or services to identify what subjects are available from a learning repository, so that those values could be used in a search metaphor. So the subjects endpoint you saw in Paul's slide, it does not require any inputs. You just directly call this endpoint, and when you invoke it, it will provide a listing of all the subjects that are supported by the learning provider. In this case, you get a bunch of subjects, and So let's see if we can identify some hierarchy here. So with science, you'll see the identifier as being 2, and then let's see if I try to find. So then we come across this biology subject, which has a parent as 2, which is science. So using this data, you can, in a way, build the hierarchy. The idea here is that a calling service or application would probably not call this as frequent as the search endpoints, primarily because this data does not change. And realistically, what we have seen is this is called probably once a month or every 2 weeks or even once a quarter, and the application keeps this data in their table and use the value in the search calls. So that's all about subjects, and I'll show an example where we are using some of the values from here in a minute. Let's switch over to the actual search call, walk through a very simple search call using the search parameter, which, as Adam pointed out, it's unlike all the other parameters in the API or in the specification, where it's defined to run against specific metadata element. This search is a way to run search queries against multiple data fields on the learning repository side. Of course, the implementation depends on the LORs and the provider side, so it's not defined by the spec itself. So in this case, in the URL that you're seeing, it's a very simple searching for learning resources that are intended to teach about polynomials, and we are limiting the results to 25. And again, you'll notice that there's the tilde that Paul was referencing. And so we have used that as a way of saying that, hey, give me all the resources that contains polynomials as a teaching element. So let's see, when we run the call, now this is a very simple call, so we have not specified anything about pagination. We have not specified anything about restricting the metadata that comes back. So if I expand one of the result set, this is all the metadata that in this case, the provider is making available by default. So most of this was touched by Paul, so I'm not going to go into it. I'm going to just touch on subjects, as you see here. So in the subjects API, we have seen that it returned data in the parent-child relationship format, and so here as well, you'll see that. So in this case, this learning resource is for Algebra 1 subject, which is under mathematics. So let's try to build on this simple call, and let's see if we can add to some of the conditions here. Let's pick maybe a subject. So we'll say, let's try and find all the polynomial resources for subject area of, let's just pick Algebra 1. Because we saw at least in one result it was Algebra 1. So in this case, again, this is a way to build on the search criteria. Realistically, what we have seen is people tend to be more specific in their search by adding more items, more search criteria items, rather than just one element where the search is very broad. Again, there are use cases definitely for both sides. But if you want more specific search results, this is a way of chaining the different criteria. So in this case, again, all these result sets that comes back, according to this law, satisfies both these conditions. Now, before I go into building this more, I wanted to just point out one item that we have not touched so far is under the header, we have, per specification, we have this X total count, which contains the total number of results that match the search criteria, and as a response to the API call, the provider includes that data in the header. So that way, when you're thinking about paginating, you have a reference on calculating that. And also a sense for what is the size of the result set. Now let's build this a little bit more. So far we have seen that we are collecting everything that the provider is returning. Let's just say that we are not interested in all of these things, but we want only few items from for the metadata elements, and that we are specifying here. So say using this fields parameter that we saw in one of Paul's slides, we can specify which pieces of the metadata we want to consume. And this is there, of course, to give you data set that is applicable in your context. So for example, if somebody is not caring about thumbnail URL, then they may choose to just get all the metadata elements except the thumbnail URL. So that is one way to limit the metadata that comes back to you, and also control the size of the package that may come over the wire. Now in this case, this LTI specification does a really good job at seeing what is out in the industry, standardizing it from a metadata perspective. But while we were building this specification, we noticed that we needed to allow for some flexibility for providers to send data which is not part of spec, at least the first version. So we introduced this extensions field, and it is nothing but a key value pair. And so in this case, you'll see 4 data elements that are not part of the original LTI specification, but in this case, the provider is sending these data elements which are unique in their repository. And so if you are working with a learning repository that has unique data elements that has not made its way to the spec, know that the spec still allows to accommodate for search calls where you can receive that unique data element. And the other point is over here, just to close this, is any of the extension items that you see here is not just from a metadata perspective in response, but you can also use that as a filter criteria. And all you have to do is, in the end, you just put extensions dot, say if you're searching for responsive content, you would put extensions dot responsive content is equal to true, and that would act as another filter criteria based on that specific item to narrow the search results. So that's at a very high level in brief about the search field and about the extensions and how we can go about building a chained conditional call. What I wanted to also just spend a couple of minutes, we're getting close on time here. So one thing I wanted to touch is just show error scenarios and talk about how to identify when there is a 0 results coming back. So let's just consider an example where we are trying to create an error. So I'll just very simply, I'll just give a different parameter name that is not part of the search specification. And in this case, you saw the error being generated. Again, this IMSX, this is IMS defined error messages and error codes. So we just follow that. In this, it specifies that it's an invalid query, and you'll see a failure. And of course, the severity being error. In case if there is an authentication required and you are trying to make a call that is unauthenticated, then you'll get an authentication related error here. So that's an example of an error scenario. Now, if I try to create an example where the result set is 0, let me see if I just put a subject that's not there. Let's just say we're trying to filter on a subject that's not available, and it's an AND condition, so hopefully it returns 0 results. There we go. So this is a successful, as far as the specification and API is concerned, this is a successful launch. It's just that the result set is empty. And so there are two indicators that the call was successful, but the result did not match any data for the learning repository to return. One is, of course, you won't see an error, and you'll see the resource element being empty. And then if you go to the header, you'll see the count to be returned as 0. So these are good indicators that the search did not match, the search criteria did not match anything in the repository. So basically, you filtered yourself out. And this could, as you start, just one word of caution as we are thinking about implementing specific scenarios, it's very easy to add so many conditions that you start filtering yourself out. So we need to understand where that balance is and which parameters provide that useful data back while still being specific. The other last item that I want to touch is going back to our polynomials example and going back to our default metadata. Oops. Did not like that space. There we go. So in more than one instances, actually, we were a question came up by audience members around how different repositories supporting different metadata elements, how does a calling application know which ones each repository support? So there is a cheat way, while we are working on the LTI Resource Search group to answer this better as an endpoint item. Right now, there is a cheat way of identifying what is supported is we can make a very generic search call, could be anything, and you look at the default metadata that comes back, and for most cases, that is a really good indication of what is supported by the learning repository. So while we are working on our side to try and come up with an endpoint that specifically defines for every learning provider what is supported, till that time, this is a good place to start. I'm going to wrap up.
Can I add a parenthetical to that, Vikash?
Yes, Adam, please.
To that point about I think there's while it's certainly true that some LORs may not have a lot of data or may not have data for certain attributes and other LORs may, it is important as far as compliance for certainly for a provider that if you get queries on things on attributes that you don't particularly care about, or requests for fields that you may not track, you still need to handle it gracefully. In other words, if you don't care about it and it causes no results to come back, that's fine, but you can't, all of those fields must be supported as far as either responding to it from a query or if they are requested in the payload, including them in the payload, even if they're blank.
Yes, thank you for that, Adam. Good. So my last item before I hand it over to Jill is, while you saw all these presentations and demos, if you're eager to test it out for yourself, of course, feel free to use Adam's open source code, download it, and that's a really, really good place to get familiar and play with it. We also have, if you go to novationlearning.com, developers, there is a tool for LTI specification. that you can play with, and it builds the URLs as you are filtering and searching for different criteria, and provides you a pretty view as well as a JSON view of the metadata. Of course, knowing, so in this case, I'm searching for, say, mathematics. Let's see. And so it builds the URL, the API call, subject mathematics, some of the extension parameters, some of the metadata fields that is selected here. And then what is interesting is it also provides a JSON view of the data that comes back. So this would be another place to just go and play around and get familiar with the specification, get the feel for the type of data and things like that. And that's it from my end. Yep.
Thanks, Vikash. Really appreciate all of our presenters today in sharing such great information about the implementation of LTI Resource Search. As we are closing, if you want to stick around for a minute, we might be able to answer one question that's come into us. We'll try to get back to you individually if we don't have time to get to your question today. I just want to note that Learning Impact Leadership Institute is coming up in May. We will have a boot camp for LTI Resource Search during Learning Impact, so we encourage you to attend. So one question for the group, maybe I'll let Adam answer this one. Which LORs currently support LTI Resource Search? Does Canvas Commons support it?
So today, of course, the spec is public, so we really don't know everybody that supports it from a provider and a consumer side. I do believe that from the provider side, in terms of certified implementation, that's what IMS is able to track much closer. So for certified providers, I believe the list is ACT's Open Ed product and ACT's Novation product. Although we do know there are several more implementations in the works, and it wouldn't be appropriate for us to comment on those. And then we do have several certified consumers, but again, you know, we wouldn't know everybody that has implemented a certified consumer, because people can just use the spec as they see fit without necessarily getting certified by IMS.
Okay, thanks very much, and thanks again for everyone who's participated. I know we have gone over. The recording will be made available to you. You'll receive an email as follow-up to this webinar, and we will follow up with individuals who had questions that we weren't able to get to today. So thanks again, Paul, Adam, and Vikash for the presentation today, and thanks everyone again for joining. Take care.
Thanks, everybody.